Next is if we have some other indeterminate forms. L'Hopital's rule is only allowed if we're doing 0 divided by 0 or infinity divided by infinity. Here in this first example, if I have the limit as x approaches infinity of x times the sine of 1 over x, well, x is approaching infinity, so that I've got an infinity, but then sine of 1 over x, well, 1 over x approaches 0, and the sine of 0 is 0. So I've got infinity times 0, which is not necessarily 0. So I need to get this into a form that I'm allowed to use L'Hopital's rule on. And to do this, I'm just going to do some rearranging, and what I'm going to be doing is say, I'm going to rewrite this x. And this would be the same as doing my limit as x approaches infinity of the sine of 1 over x divided by 1 over x. If you go through and do division by fractions, that would take me back to where I started. And this is a very common thing to do when I have infinity times 0. Well, now I've got sine of 1 over x is going towards 0 as x goes to infinity, and 1 over x is going towards 0 as x goes to infinity, so I've now got 0 over 0, which allows me to use L'Hopital's rule or, because I'm running out of space on this, I can also think of this as well. If I change 1 over x to h, well, this would become the limit of the sine of h over h. But then, as far as what h is approaching, well, x is approaching infinity. We said 1 over x approaches 0, so h approaches 0. And this we've already found out is 1. So I know it seems weird, but we're saying that as we approach infinity times 0, we're really approaching 1 in this case. Second example here, and I'm sure there'll be questions on that first one. As x approaches 1, well, natural log of 1 is 0, so I've got 1 over 0, which is infinity, minus another 1 over 0, which is also infinity, so I've got infinity minus infinity. In this case, we want to combine this into one fraction, so we need a common denominator, which would be x minus 1 times natural log of x. And that's our common denominator. And so this would become the limit as x approaches 1 of x minus 1 minus the natural log of x all over x minus 1 times natural log x. Well, now when I plug 1 in, that's 0 minus 0, so it's 0 in the numerator. I would also have 0 in the denominator. I can now use L'Hopital's rule and do my derivatives. So I'd have the limit as x approaches 1. Derivative of x minus 1 is just 1. Derivative of natural log of x is 1 over x. In my denominator, I'm going to have to use the product rule. So first times the derivative of the second plus the second times the derivative of first, which is just 1. And so now, if I try to go ahead and do a little simplifying here, because if I try to substitute this, it's going to be 0 on top and 0 on the bottom still, so maybe if I do a little simplifying, this will help. So that's going to be, for my numerator, x minus 1 all over x. For my denominator, I'm flipping it because I'd be adding that, so there's going to be an x on top here, and this would be x minus 1 plus x times the natural log of x. And so I've got x's that cancel. Still 1 over 1. So I'm going to do my L'Hopital's rule again. or I'm sorry, it's still 0 over 0, so I'm going to do L'Hopital's rule again. Derivative of my numerator is going to be 1. Derivative of the denominator, so I'm going to have 1, then a 0. Then my product rule again, so that's first times derivative of second plus second times derivative of first. Well, now when I plug this in, well, that's going to be 1/2.